Good morning, everyone. Guys, taking a look here at 5.3 polynomial functions. Guys, we're going to start looking at graphs specifically. We won't be doing any graphing today. We'll use some technology to maybe tomorrow or next Monday to graph some polynomials. But today we're just going to try to get a basic understanding of polynomial functions. Okay. So let's start. Polynomial functions, guys, a polynomial in one variable. It's an expression of the form, as you guys can see, an x to the power of n. And so it's, guys, what this is trying to get at is that the first degree, so we're very familiar with a quadratic function, guys. Let's go 2x squared plus 3x minus 1. Guys, that is a quadratic function. Guys, polynomials in one variable just means they have one single variable, x. Even though sometimes, I guess, we write them as y equals as well. But one in the function part, okay? So one variable, and the degree is decreasing. So highest degree term first. Okay? And so here they've got some examples of polynomials, constants, linear, quadratic, cubic, and then just in general. Again, that odd formatting, not terribly concerned there, okay? Highest degree term comes first. All right, guys, this idea, so degree, I know we've worked on that in 5.1. It's just the highest exponent. Okay, leading coefficient, guys, that's the number in front of that highest degree term. So in this linear case, okay, well, the degree is 1 because it's x to the first power. The leading coefficient is 4. That's the number in front of the x to the power of 1 term. Guys, the second quadratic, degree is 2. Degree is 2. Leading coefficient is 5, the number in front. So the leading coefficient, that's the number at the start of the polynomial. Okay? Guys, we're going to skip over B and 1A on these examples. They're not polynomials. I'm not terribly concerned if you can identify what isn't a polynomial. I just want you to understand what is a polynomial. So, and excuse me, these cases, or these problems, these examples, guys, we're just going to identify degree and what the leading coefficient is. So, example A here, the degree, well, what is the highest exponent we see there? That's 5. The degree is 5. The leading coefficient, well, what number is in front of that 5th degree term? The leading coefficient here is 8. Okay? Example C. What's our highest exponent? Ooh, this one's kind of tricky. It's not written in what we call standard form. Guys, the degree, the highest exponent, is 8. Okay? Because it's not written in standard form, the leading coefficient, well, it's not the number out there in front. It's not this 3. We need to write it in standard form. So that first term should be the highest degree term. And then it just decreases. So negative 4x to the 8th plus 3x to the 4th plus 6x cubed plus 2x. Okay, now your leading coefficient is negative 4. Okay. 1b, well, this one that's in standard form, highest degree to lowest degree. So the degree of that highest degree term, that's 6. The coefficient of that term is 5. Leading coefficient's 5. Guys, 1c is not in standard form. I want you guys to practice putting that in standard form. Highest degree, highest exponent term first. then just greatest to least. So then 8x to the fourth, negative 2x cubed, and 3. So, guys, once it's in standard form, easy to identify degree 6, leading coefficient. Well, what's it in front of? So what makes negative x? Well, that's a negative 1. Okay. Let's take a look at the next page. Okay. A polynomial function, it's a continuous function that can be described by a polynomial equation in one variable. I'll give you an example there. Okay. Guess polynomials, you can plug any x value in. The domain is all real numbers, so you can plug in any domain value and then get x value, and you can get a y value back out, or a range value. All right, so I said I wanted to get a basic understanding of graphs, guys. Part of that basic understanding is talking about end behavior. Guys, the end behavior of a graph, guys, when we draw those arrows on our graphs, we do it for a reason. That means the graph continues in that direction forever. Okay, that's the end of the function. It'll just keep going in that direction forever. Nothing else interesting, no other turns will happen in the graph. Okay, that's why we put, if you're looking here at this cubic function, that's why we put arrows here. Okay, so it's going to continue going up for the rest of the x values to the right. Okay, well, to the left, that function is going to continue going down for the rest of those x values. And so, guys, there's a way to describe end behavior. Okay, as I just so I said as x goes to the right. Well, what numbers are out here to the right? What's like the biggest number you could think of maybe out there? Maybe it's 1,000,000. Okay, so maybe 1,000,000, some x value way out here to the right. Well, beyond that would be 2 billion, 3 billion. So x goes on forever. So when we describe end behavior, we're going to describe it as x goes to infinity. In fact, we'll say positive infinity. So as x goes to the right, you can think of this as the right. As x goes to positive infinity, that's the right side of the graph. If we're talking about this quartic function that we've been focusing on here for a second, what is the function? What's the blue line doing? The blue line is the f of x. That's the function. Well, where is it going? It is going up. It's going up, which is to positive infinity in this case. All right? And so what if we wanted to describe the left half of this graph? Okay, what if we thought, well, what x value is over here? Well, negative 1 million is somewhere over here. Negative 2 billion, negative 3 billion, and so on. So there's right end behavior and there's left end behavior. The left end behavior we describe as x goes to, or as x approaches negative infinity, goes to the left. Guys, what's the function doing? In this case, guys, the function's going up, which is for f of x, that is positive infinity. So that's how we describe end behavior. Okay. It's important to understand that end behavior is related to the degree of a polynomial. Scroll here. Um, if the degree is even. So the degree is even if we're looking at these examples, guys. If degree is even, here the degree was 2, here the degree is 4. Okay, if the degree is even, end behavior is the same. To the left and to the right, the end behavior is the same. We saw that in that quartic example. The function was going up in both cases. It was going to positive infinity in both cases. Okay? So that leaves us, well, what if the degree is odd? If the degree is odd, well, and behavior is opposite. It's not the same. Okay, so, well, let's look at an odd function up here. An odd function would be a function like this cubic function. Guys, one of the functions, one of the f of x, one of the arrows was going up, the other arrow was going down. They're opposite. Degree 5. One of the arrows goes up, one goes down. The end behavior is opposite. Okay? So guys, I want you guys to be able to describe end behavior. Look at a graph and be able to describe end behavior. Okay? I'm going to stop there today, guys. We've gone on for a while here. A little over 10 minutes. So I'm going to stop. It's a good stopping point. I want you guys to practice describing end behavior. Okay? All right. I'll put a couple questions up as a Canvas assignment. If you guys have questions, send me a message. I'd be glad to answer any questions I can. Okay? Have a wonderful afternoon.